I lead the development of various initiatives that we're branding as Wazi, and so I want to walk you through what are those different components and how does today's modern enterprise application development in the hybrid cloud look like. And so just to set the context of the presentation, we're talking about modern development practices. DevOps is like the umbrella term for the ideas that we're referring to. So when we talk about enterprise modernization, we mean the adoption of modern practices and tools into the development lifecycle for enterprise applications. So we're still talking about COBOL applications, PL1, assembler, and we're supporting all those languages and technologies for these applications, but integrating them with these modern practices. So adopting agile development, for example, is like not only the adoption of new development practices and technologies and tools, it's also kind of a cultural change within an organization, a different way of how to build and release products and organize the development lifecycle there too. And the other goal that we want to achieve here is that we want to unify the distributed world who already does DevOps for many years with the enterprise application world, that we really break down the silos, that there's only one set of practices an organization does and executes on and breaks down the silos and really gets rid of all the differences, making ZOS and the mainframe as part of the network as any other system that you're building for and building with. Right, so the end goal is really such an end-to-end two-chain pipeline for enterprise DevOps. And so the challenges that motivate this is that like the shift of skills and the availability of new developers within the organizations, it drives a lot of those changes. So developers working on enterprise application retiring, the next generation coming in and bringing on board many of these practices and many of those tools, and they expect to use them. They might not be satisfied in their job if they have to work on a green screen 24/7, but rather bring in the tools that they're used to be working with for many years already, such as VS Code and Git and so on, and drive a lot of those changes, which can then utilize the advantages that people see in the spaces of increasing the increments of releasing and shipping products more frequently, reducing the amount of manual work for CI/CD tasks, and adding and integrating automation into these processes, and addressing a lot of these problems that people feel as challenges in the enterprise space. And so the question would be, what are the right technologies and tools to choose? So here's some survey results around technologies that people are using these days. As you can see, open source plays a major role, that in 96% of the organizations that were asked in these surveys really say that there are pieces from open source that they're considering, that they want to utilize. And many of these technologies that we're referring to in this presentation, such as Git or VS Code or Red Hat OpenShift, they all have their root in open source. Often they're layering on top of open source. As we do with our zDevOps solution, you will see that there are open source projects that we are actively investing in and participating in, and then we're building those commercial solutions on top of that and layering these on this fundament of open source, which allows you to integrate with everything that these open source solutions integrate with and run on those platforms. Plus, we're adding ZOS as a platform that these solutions can run on. So the vision really is that we take the best of the mainframe development world, the best of the distributed development world, and bring them together into this new hybrid toolchain and DevOps lifecycle that allow you to integrate tools now from the distributed space that work well in these environments, make them workable on the mainframe, on ZOS, and integrate them with technologies that are very mainframe specific. So the idea is such a pipeline. So we show you here different stages in the pipeline, from coding, building, provisioning, deploying, testing, releasing, and so on, and then technology choices that we're considering, right? So we're not saying that you should use all of these tools, but these are different options that are available to you. You can choose GitHub or GitLab as an example of a SCM that we use in your development space, as well as combine them with technologies from these different stages of the pipeline to build up your integrated pipeline. And again, these technologies will then integrate seamlessly with the distributed technology stacks that you might already be using or planning to use. So the vision is that for z/OS to be widely available and vibrant choice of a platform in hybrid cloud environment, and to provide a modern cloud-native developer experience for z/OS that is consistent and familiar with all developers. I'd say if I know how to edit my code in one space, such as a distributed Java application, I want to use the same tools and processes to maintain my COBOL application. So we're going to talk about today two major offerings in that space. So we're going to talk about the IBM Z and cloud modernization stack, particularly focusing on the middle point in here, the Agile Enterprise DevOps part of that solution, as well as the Wazi as a service, allowing you to bring capabilities around z/OS into the IBM public cloud. We will talk about on-prem scenarios as well as IBM cloud scenarios, right? Cloud-hosted scenarios, and how you can mix those two, or you can choose one over the other depending on your situation. All right, so first I want to tell you a little bit about our own journey developing the Wazi portfolio of components that are part of these packages, right? So we set out to bring in a new type of DevOps and editing and development experience to the z/OS group by building on top of open source projects that we were involved in, right? So Zoe is a key name in here. So when the Zoe project started, we were working with business partners to bring together key technologies that allowed us to easily integrate new technologies such as cloud-based and cloud-native development with the mainframe. So the first step was to provide connectivity APIs to z/OS. So ZSMF was made available, RSE, something that we provide with our IBM developer for Z for a long time, SSH and FTP, but also the Zoe project itself developed new APIs to integrate and access z/OS systems from anywhere within your network. And so client SDKs were produced there that you could use to build new case tools on top of that or with it. So Zoe CLI is an example I want to show you where you run command line operations out of your development environment, such as your PC or Mac laptop, to interact directly with z/OS as MVS or USS or JES, and have this ability to automate and script against these systems and do workflows and so on. And then building on top of that graphical tools and a new modern environment such as VS Code, Eclipse Theia, Eclipse Shea, as well as a platform that gives you the ability to integrate enterprise application capabilities for language support, like we added COBOL, Pier1, Assembler Rex, language servers that integrate with these environments, as well as interactions with the z/OS using those SDKs and APIs that I was mentioning before to create a graphical browser that allows you to navigate your data sets, open up a data set member, which might be a COBOL program, added that, and debug it, and perhaps then submit it via a pull request into an SCM to start a automated build process. Other layers that we put on top of that are bringing these solutions into the cloud and giving you more choices. So VS Code and Theia are desktop solutions, but then Eclipse Shea takes these APIs and brings them into the cloud so that you can run them directly without installing anything on your laptops from the cloud and be able to edit things from there, as I will show you. And then run these things as part of OpenShift. And the Red Hat environments that gives you other technologies that you can integrate with, such as pipelines using Tecton and so on as well. And then we utilized IBM's best practices for providing cloud-based offerings, either as cloud packs or on-prem or within the cloud through IBM's public container registries, and going through the IBM certification process, and then donating back to these projects all the enhancements and security fixes and refinements that were kind of required to do for the certification, and bringing them back to the open source projects where the technology originated from. So let's give you a few examples and what these technologies are. I mentioned Zoe and the Zoe CLI. You can see here some examples for commands that you can execute. So you can interact with the mainframe files, downloading, uploading, like a dataset member, doing this through command line, and then through our integrations with Zoe Explorer, doing this in a graphical way, right? So on top of the SDK that was developed to create the Zoe CLI, we basically built a VS Code extensions on top of that gave you this ability to do many or almost all of these command and operations through graphical means. So query the data sets based on naming patterns, show me all the members, open one, submit a job, as you can see here, if it's a JCL member, and integrate seamlessly in VS Code to support these capabilities. And then integrating this with alternative protocols. So the Zoe project very much focused on zSMF as one technology, but for our existing customers who used ZOS Explorer or IBM Developer for Z, they were familiar with the RSE API that these technologies provide. So we integrated this as an alternative means to zSMF, so that you can choose based on the technology and infrastructure that you already have. You might use zSMF, then you're okay, but you might not have configured zSMF, but rather utilize RSE today with IDZ or ZOS Explorer, and then you can use those as well for command line operations, or those VS Code tree browsers that I was showing you. We are integrated with other technologies as well, like one other alternative could be FTP, which doesn't cover all of the capabilities that RSE and zSMF has, but a significant subset, so that if you only have FTP enabled on your zSystems, then you can use that as an alternative as well. And again, you have command line operations as well as those graphical editors available for that. Then we layered on top of that the language support that I mentioned. So supporting the main languages in the enterprise space, COBOL, PL1, but also added then later assembler and Rex, as people were asking for these languages, and then having the ability to utilize them in these different editing environments centered around the VS Code APIs, which have been implemented by the Eclipse Thea project, by the Eclipse Shea project. And so we write these language servers once, and then they can be utilized in these editors. And the language server core parsers and technology is actually being reused from our Java-based offerings, such as IBM Developer for Z or the Wazi developer for Eclipse. So they share the same code base, so the same COBOL parser that supports the latest language versions is available and works equally in all of these tools. So most of the capabilities around language editing will be exactly the same. And I forgot to update the slide. We are on the latest version, 6.3 and 5.3 and so on. And we will continue keeping up to date with always the latest language versions for these technologies. And then we added another layer on top of that, so automation for the developer, so dependency-based build integration, so that out of these IDEs, such as VS Code, I could quickly run a so-called user build. So a build of just one program that gets then compiled on the ZOS system and executed if necessary, and I can look at build logs and make fixes and then rerun the build until the application behaves in the way that I want it to be. So we want to really make the development experience very, very similar to someone who does Java development or TypeScript, JavaScript development in VS Code, right? So those standard patterns that people are used to from Gradle or Maven in Java or NPM in the JavaScript world. I'm cloning my repo, I do an npm install perhaps, and an npm build and an npm run, npm test. So these type of gestures we wanted to replicate for enterprise applications as well, so that these next generation developers feel immediately at home and comfortable for that. And so here are the roles of personas that we're targeting with this. So particularly on the right hand side, you see our developers. So we distinguish Deb, the early tenure application developer. So she might have a background perhaps in a distributed space, created Java or TypeScript applications in the past, and now working on an enterprise application, or coming in from university and have perhaps not too much exposure with this yet, but perhaps learned about Kubernetes at the university and worked with TypeScript, JavaScript applications, and wants to be able to reapply the best practices that she knows on these types of projects there. Whereas Kathleen, the last generation developer who works in mainframe for many, many years and knows many of the best practices there, worked perhaps with all kinds of development environments before, but should be onboarded with these same types of technologies in the same way, but as well as having actually choices between what types of IDE and editor she would like to use. If she prefers an Eclipse-based editor, she can use that. If she would like to learn what Deb is doing with VS Code, then she can also do that, or even go back to the green screen and work in this environment with these technologies as well. And then we're adding new personas. Of course, we have the system progress we always had, but then cloud administrators, Todd, as you will see, that we're lifting up these technologies into the cloud, as well as early 10 years US systems programmer who will perform specialized tasks, perhaps such as providing reusable images for what I will show you is called Wazi as a service for running in an emulated environment ZOS applications. Just coming back to Kathleen's skill set and experience. So Deb might be entirely familiar with setting up VS Code and installing VS Code extensions and configuring like other prerequisites such as Java or Node that we use to build these technologies. Zoe CLI is a Node-based technology, so you need a Node runtime environment. Our language servers share their code base, as I mentioned, with IDZ and ZOS Explorer, and require Java as a runtime, right? So how to install and configure all of these things might be no problem for Deb, as she's familiar with those, but for Kathleen, this might be a challenge. So to address that, we want to get her started very quickly as well. We lifted this technology stuff into the cloud and provide a very easy means for Kathleen to get these things running without installing anything. So here we talk about some code-ready workspaces based on the Eclipse Shea open source project that we then configured for the ZOS enterprise space and called it Wazi Developer for Workspaces, as it provides then a stack tailored for the ZOS audience. So the idea would be you have this kind of getting started dashboard with pre-configured technology stacks that combine technologies that might be needed for a specific project. So Todd, the administrator, can customize these and set them up for his development organization, and perhaps combine things like Java with COBOL if you have a project that utilizes both technologies, and create new tiles in here. So Kathleen can just come in here and select one of those tiles, and then you can see an entire technology stack will be configured for her in the cloud. So it is based on container images that just get instantiated. So there's an image that has our COBOL editing capabilities on it, together with the Zoe CLI and the Node.js prerequisite, and configures all of these things just with one mouse click. So Kathleen will come in here, specify the Git repository she wants to use, the technology stack, and this will be then instantiated to her within a few seconds, without needing to install anything, and running this entirely in the cloud. So as I mentioned, here's some technical picture. How can Todd customize this? So this is all based on different container images. So we and Red Hat provide a large set of example images and Docker files that you can use as a starting point. You can entirely customize them and create and publish your own in your in-house registry or the OpenShift registry, and then utilize those through these tiles. So Kathleen doesn't see any of this. She will only see the end result, which is a customized dashboard with a technology stack that Todd has prepared and published into an environment such as OpenShift. So here's a summary and a small architecture picture of how such an environment might look like. So we have OpenShift here in the red box on the left, and in there we're running the Wazi developer for workspaces, which is based on the Red Hat code-ready technology that runs various technologies as containers inside, running zSystems, running Java, running the editor components so that you can directly use them. And then on-prem, you can combine it with the Wazi sandbox, which is an emulated technology based on IBM ZDNT technology that runs also on OpenShift on-prem, is emulated on x86 hardware, emulating ZOS there, and then can be directly integrated with these editors. So you can run entirely on OpenShift on-prem, and developers really don't have to install anything. The administrators set it all up and then instantiate these editors or the sandbox for the developers, Kathleen and Deb, and they can get going. But they can also integrate and connect to such a sandbox from other IDEs. So you see a box on the right for Wazi Developer for Eclipse, a box for Wazi Developer for VS Code, and pick and choose the pieces that they want to use. And all of these come with very similar technology stacks, so that you can run command line operations. You have a graphical browser to access your data sets, and so on, as I will show you in the demo. All right, switching over to the other technology stack that I was mentioned. So far I was focusing on the on-prem setup, how we can in OpenShift run these things on-premise, but the some major pieces of this technology stack you can also run entirely in the IBM cloud, as I will show you in the demo. So you can run the developer for workspaces code-ready technology stack in the public cloud, fully protected by so-called virtual private cloud that runs behind a virtual private network that you can connect to, as well as then combine it with a new offering that we have announced, which is called Wazi as a Service, which gives you ZOS in the cloud running on real native hardware. Right, so you will set up this virtual private cloud, as I will show you in the demo, configure it securely, set up a VPN to access it, and then utilize this as a development environment. So every developer can have their own ZOS system if needed, or developers can share one if they collaborate and do the development activities against the cloud, on the cloud. And they will have still the same choices of IDEs, as you will see as well. So this integrates seamlessly with IBM's the infrastructure as a service stack. So you have probably heard about many of these layers that we're providing. So on the physical hardware, right? So we have the virtual private cloud virtualization platform that runs these ZOS VSIs. So they're emulated, but they're emulated against real hardware, right? So they have a lot of advantages over the x86 emulated hardware in terms of performance and I/O performance and so on. And they run in the cloud as part of the virtualized platform. And then they can be combined with other cloud offerings, such as the FS Cloud, which hardens such a cloud environment for you, providing a lot of security features as well as auditing features in combination with these technologies, so that you can establish a trusted environment within the IBM cloud to do your development. So these are as another picture of different building blocks that you will set up in here. So you will start on the network side, either choosing a VPN as a service that IBM Cloud provides, or direct link connection to the cloud, configure your virtual private cloud through that, and then instantiate these so-called virtual server instances that then will use a S396 hardware system to run on, and then we provide a stock image for def and test that has already pre-installed and pre-configured the runtime components that you need for those different technology stacks that I mentioned earlier, such as the user build, right? The COBOL compiler, the debugger, for example, is available on there and configured, can be directly be used. Other components such as the RSE to interact with it, as well as the USMF as an alternative, SSH, and everything really that you need in combination with this development stack that I mentioned to interact with the US and work with it and do your development work. Okay, so the idea really of integrating this in your dev and test pipeline would be that you use this for development, developer-centric, right? You build against these systems locally, the user build, versus the actual final build you would still run on your on-prem zSystems. But you can scale up development, giving your developers your their local environment that they can work with, or not local, personal environment that they can work as for the development space, and run personal pipelines on it. As you would see as well, I'll show you a GitLab integration to do this for development, build and test. That is then seamlessly integratable with the actual deployment and end user test environments that might then run on real hardware, not real hardware, on on-prem hardware. They're both using real hardware. So modifying the picture that I showed you earlier, you can still see the Red Hat OpenShift based environment is still available through that, can be co-deployed into the same VPC for the IBM Cloud, and then combined with a Wazi as a service dev and test system, right? So such an emulated on real hardware system, and that can still be accessed through any other environment, such as the Eclipse-based editor, VS Code editor, and be combined with things like pipelines that you're running either inside or outside of OpenShift on a Jenkins server perhaps, or a GitLab server, depending on what you want to utilize. So here's a technical picture of what I want to show you now in the demo, where I'm basically setting up such a VPC, or I already have it configured, and then have VSIs deployed into that, into a subnet, and the access to these VSIs will be through a VPN if I'm connecting through a VS Code client through that, or the OpenShift cluster that I'm using for Wazi Developer for Workspace, you can see is deployed into the same subnet, protected in the same way by the VPC, but then these instances can see each other. So I can directly utilize the VSI out of my editor by accessing it through the way, as well as have deployed a GitLab server into the subnet through IBM Cloud as well, and then even run GitLab workflows through this environment that are entirely set up in the cloud. All right, before I start a demo, let's just perhaps pause for any questions that you might have.
Nothing here. I see nothing in the chat at the moment, thanks, Peter. So I think you're good to go straight into the demo.
Okay, so then let's start here in IBM Cloud. So I logged on to cloudibm.com. You see your standard dashboard where you come in. I can already see all the resources that I have available here. And so we're navigating directly into the virtual private cloud homepage of IBM Cloud, right? So this is IBM's infrastructure as code solution. So you basically create a network through code by describing it through cloud technology frameworks and deploying it through code in here. So you can use a graphical UI that I'm utilizing right now, but you can do this entirely through automation as well, and set up and destroy these virtual private clouds on demand for a particular project and so on. And so I have a VPC already set up for this demo that we can have a look at in here. And that VPC has a subnet. The Wazi VPC has a subnet into which I already deployed various virtual server instance, but also x86 systems as well. Right, so this is one network that I can access, and the systems can access each other as well. I can drill into here the virtual server instances detail page to look at them. And so I have two ZVSIs running in here right now, but I'm also running the VPN system that runs on a regular Red Hat one. So there's only one floating IP through everything that the VPN goes through, and all the other traffic from other clients has to go through this VPN. So I'm running here an open VPN client, TunnelBlack to be connected to this VPN, and so that my laptop can see these types of things and I can access them, such as through my VS Code editor that we'll use in a moment. And because this is the IBM Cloud, I have also other things deployed in here, right? So there's a catalog available to me in here, so I can just search for GitLab, for example. So if you just don't have your own GitLab enterprise server yet, for example, you just like to elaborate how such workflows with GitLab could be set up, then you can deploy a community edition version of GitLab into the same VPC as I've already done. So I have a GitLab CE server in here that is running where I'm running now. You can see that that's the IP address that we saw in the VSI view. I can manage my source code in here. And again, if you're evaluating these types of solutions, that's a very easy way to deploy it. But you can also integrate this with GitLab.com in a secure way, or if you have an own GitLab enterprise server, then that works in the same way, as well as with other technologies such as GitHub, Gitbucket, that can be integrated with that. Another thing that I've deployed in this VPC is an OpenShift cluster. For various reasons, but for this demo, the main reason is that I can also deploy my Red Hat code-ready development environment into that. So you can see Red Hat OpenShift is available through here. I can use the UI or automation to deploy this, and I've prepared this already. So I have a OpenShift cluster configured and deployed into the same sub network, and then we can deploy Wazi in here. So we have the Wazi developer for workspaces that I've already installed into this environment. You can see I have the list of installed operators here where the Wazi developer for workspace is already running. I have an instance running for this, so you can have multiple of these deployed for different projects to keep them entirely isolated. And you set up user accounts either by linking in perhaps with a LLDAP server or managing users locally. And then there will be one URL that you give your developers to log on to, right? So this whole administrative stuff that I just did with operators and so on will be done by Todd, but then Kathleen and Deb will get just this URL to a dashboard that they can log on to. Already logged on here as my account that will end up in this workspace that you saw earlier on the deck, and then instantiate a workspace with the technology that they need for their project. And so you provide your Git URL. If you want to clone a repo directly, you can also clone after the fact you've created these, and then you will end up, I already have a browser tab open for this here. I can't click on it because of the WebEx tools. So then they will get into this workspace. So you can see here's still the toolbar in here. You can collapse that, and then you're in your editing environment. So if you worked with VS Code before, you will see that this looks very, very familiar, and that was done intentionally. So this cloud-based IDE was designed to be give you the exact look and feel as VS Code. So that people who work on VS Code are immediately familiar with these types of environments. The shortcuts are the same, the look and feel is entirely the same, and even the code base of the extensions that we're providing has been reused, as this Eclipse Shea editor implements through Eclipse there the same VS Code API. So the language and capabilities that we're adding in here run in VS Code as well as this editor as well. So here's our COBOL a language server that will provide you with an outline view for quick navigation and various language capabilities. And then we have the same thing for Peer 1. We have it for high-level assembler as well as Rex available. And so here we have rich editing capabilities that a developer coming from Java or TypeScript is immediately familiar with. So you can hover over certain things and see where they're being defined. You can do right-click operations such as peek all references on here, and then quickly navigate to the different locations where this variable is being used. Or you can do refactoring operations. So I can do a right-click in here, rename the symbol, just do a trivial change to remove that S here from the WS trends, okay. And then if I go back into the peek all references, I will see that then this has been refactored, renamed in all those locations, right? So I can do like consistent type of refactoring operations. I can do things like code completion in here. Let's add just another new line in here, press Control Space, and it will show me all the options that I have available of all the commands that start with D in here. So I can do a display operation and add another command in here. And so I'm perhaps working as Kathleen right now. I see that I just added some code in here that I didn't clean up. And I did my refactoring of this, and I might be working on some other bug and problem, right? And I can edit with these things directly in here. There's a full Git integration that I can see here as well. So I can look at and review all my changes now side by side of all the refactoring that I did of this WS trends, okay, with my cleanup operation. So I can immediately see all the things that I've done and that I've modified in here, and then commit this to a Git lab repository. So I'm already connected in this environment with this environment in here where I have all my source code cloned from originally. So what I can do now is, where's my editor gone? Go back in here and just do a code cleanup, perhaps command and say that's what I've done in here, and then push that to my GitLab server. And what I've done in here, I've integrated this with a pipeline that I can run on GitLab. So you can see that now through the push that I've done here with code cleanup, that commit is visible in here. I started a pipeline that will go through building, unit testing, my application in the branch that I'm currently working on to see that these edits actually work. I can do this also entirely locally. So what I mentioned earlier is that we want to set up a development workspace similar to how people use VS Code today or Eclipse with Java application or TypeScript application. So one thing we're doing is we're providing automation that can be used locally. So we're providing Ansible playbooks that can be utilized now to initialize and set up such a ZOS system that I've created. So I mentioned earlier that we have created a Wazi as a service system in here that is running ZOS. You can see it running on this IP address. And when I create this instance, of course, it's an empty ZOS system. I don't have anything on it yet other than the development tools that come out of the box with this VSI. And now I need to bring in my source code that I can build it. I need to bring in test data that I can actually run and test the application. So there are many ways of doing this. In the samples that we're documenting with Wazi service, we provide shell scripts to do these types of things together with Zoe, upload commands. We also have Groovy scripts to do automation such as building and running an application, as well as Ansible script that can utilize these things as well. So first of all, initializing the local system. So this will help me set up creating actually a connection to the system that I'm interacting with. So utilizing Ansible and the ability to manage inventories in here. So here I filled in the IP address and my user account of the system that I'm utilizing with this. And then I can run this Ansible playbook, which will then create for me things like connections to the system that I can then utilize in a graphical browser. So if I ran the script, it will populate this view for me. I just prepared this just to save time beforehand. And now I can look at my data sets that I have available on the system. Of course, I forgot that you wouldn't see any data sets yet, as I have not initialized these yet. So for that, we have other scripts I would run first. So I initialize my local system to create a connection. Then I will actually build my entire application. So we have a build command in here. And then I can also do a run command that does other things, such as uploading test data that I need to actually run the application. So I mean, just execute the last one, the run one in here. So this will basically upload test data to the system and then execute the application. So the idea would be that Deb or Kathleen can go through all these steps, set up the initial local system, set up the remote system with all the programs and JCL files that she might need for building the application, as well as some things like setting up DevOps tools. We have another playbook here called Prepare the User Build, which will actually go ahead and will do a clone on the USS system, clone a standard repo for building the application that then can be utilized with Groovy scripts that we're providing to execute these things. So then the ability I will gain in here, I'm entirely set up. I have my test data in here, and I can do things like making code modifications and run an IBM user build. So instead of committing and pushing this to my GitLab server, I can just do these types of build operations within my IDE through the setup that I've done, copied over standard build script and so on, and provisioned data sets and so on that I need to actually build this application. And then I ran the build in here, the log files of the builds get downloaded, and I can look at that. And if there was a problem with the build, I can look at the errors that the build perhaps had directly out of here without leaving my development environment. And so you can imagine that you have these round trips of making code fixes, building it, and then perhaps also debugging the application, right? So the debugging would be done in a similar way. So one thing that these scripts did for building and running was also to produce JCLs for me in a data set in here that I then conveniently can use to debug and run the application. So to show you that this can also be done from other editors, let me just switch over now to VS Code. So let's assume that Kathleen, for example, worked in this environment and got perhaps stuck and wants to ask Deb now, hey, I'm stuck here, I made some code changes, but I still have a problem in here, and wants to hand this over to Deb, who wants to now perhaps take exactly the branch that Kathleen is using in here and perhaps run a debug session with this. But Deb doesn't use code-ready workspaces, she likes the VS Code. So let me switch over here to Microsoft VS Code, where we installed the ZOpen editor as well, when we installed ZoExplorer in here. And we can seamlessly do development out of here as well, right? So I run similar configuration scripts, and I have this ZOS VSI here available now to me as well, be in Deb, and I can access this system because I'm dialed in through the VPN now. I can securely access this VSI that runs in the IBM cloud, have access to data sets here as well. And I could immediately then use this to set up a debug session and run this, right? The first thing you would need to do is switch over to the branch that Kathleen was doing. So we call it here GitLab VPC. So I'm checking out now that code base in here. And on Kathleen's side, she already had things like launches configured for me that I can use to start a debug session out of here. Plus, there's one more thing that we need to do, or two more things that we need to do. We need to create a so-called debug profile in here. So basically telling the debugger where the system is that we're working and debugging with. So I'm creating this debug profile and activating this in here. So this is password protected. I need to provide my password. The debugger is ready now, and I can go back to the JCL that was produced by Kathleen and just start a debug session on the remote host by right-clicking here and say submit job. The job has been started, and now I can just go in and connect to a parked session in here using that launch that Kathleen gave me. and something went wrong. Let's see. Okay, that might have been a problem. So I can look at my job actually now in here to see if there was a problem starting the session. Looking at the jobs view, so it was 114, and there was a JCL error. And I have to see what I've done in here to break the debug. I just tried it before the presentation, but you can see I can directly drill in here. And I have a problem with I copied the wrong JCL. I think I overwrote something when I was running the initialization script. So I was using the wrong compiler library in here. So I would have to fix the problem. I'm running out of time now, but I would then be able to start the session again. So if there are any questions, otherwise I just could quickly do that here. Let me delete this one.
No questions in the chat at the moment, Peter. You're obviously blowing everyone away with this ability to be able to develop on the cloud with GUI front ends. Good stuff.
Okay, let me regenerate that JCL again. Not sure where I overwrote it with the wrong version. So what's happening is I'm supporting with this VD script multiple setups. So in our Ansible inventory, we actually supporting we can configure more than one system. So here I could also do the demo with a Wazi sandbox that was these x86 emulator systems. And the version that we have there uses different version of the compiler library for COBOL. And somehow I must have mixed up those two, providing in the JCL for my debug session the wrong one. So hopefully this gets now corrected if I just rewrite everything. All right, let me refresh this. Okay, I think that's the right one. So let's do another submit job. 123, let's have a look at that one. Okay, this one is active now. So now I can connect to this APAC session. Prompted for the password. Okay, and now I'm in debug mode. So now I can start stripping through here. Going directly here into my environments. I can set breakpoints in here. And then you can see I updates here on the left-hand side, so I can review my variables that I have in here, and so basically step through this. And Kathleen and Deb, they can do a debug session. I used to do this perhaps on Java or TypeScript. So the user experience again is very similar to these environments, and you can see that I can seamlessly switch between working in code-ready workspaces to VS Code. As well as I could have done the same thing now with the Eclipse-based environment. So here we have Wazi developer for Eclipse. It looks very similar to IBM developer for Z. And I, as you can see, I have also access here to these types of these data sets that I was using. I could open the COBOL program that got compiled in here directly. I have an outline view. I got refactoring operations. So we give really developers a choice which environment they would like to use. It's based on their background. Okay, that concludes the presentation. So we have ways of exploring these things. So the IBM Z Open Editor that runs in VS Code is available for free, together with a Zoe Explorer that we're developing in open source. You can try this. You can also try running these in an Eclipse share environment. So we provide instructions how you can get a trial environment at Red Hat using the Red Hat sandbox and deploying our editors in there, and just getting feel for how these developers work inside the cloud, as well as provide other ways of trying these things out in the Z trial. We got various scenarios covered in there for various technologies that we're covering in here. So we can provide you with this list of resources to get some hands-on experience and elaborate and try these things. Okay.
Beautiful. Peter, thank you very much for that. Very comprehensive presentation, that, and great demo, and always gutsy. I've always felt to run a demo live, so kudos to you for doing that. I'll just check the chat box here. I can't see anything more in the chat box. George or Jenny, have you seen anything that I've missed in the chat box?
No.
Doesn't look like it. Okay, so I think at that point, I may just stop the recording.